Welcome to today's webinar. I'm your host, Jeffrey Palermo, and we have a really great group today. We're going to talk about the topic, why your software team can't move fast. The secret is hidden in plain sight. We talk a lot about developer productivity, speed, throughput. We also talk about quality and stability and its relationship to that, but we're going to hone in on just diagnosing if the team is not moving as fast as we want it to, why those reasons may be. And there is a lot that cannot fit into this webinar format. We have lots of other content, and of course, if you guys want to follow up, I love meeting with various people. So we're just going to go ahead and do that. And as we go along, forward slide, a little bit about ClearMeasure. We are a software architecture company empowering software delivery. We're enabling in-house .NET teams to be self-sufficient, able to establish the quality that they need and achieve the stability that's necessary and increase the speed to whatever level is necessary in the organization. And we primarily work with teams who are Visual Studio subscribers, so use the Microsoft development platform and all the different piece parts that fit into it, which includes so many different technologies, but kind of Visual Studio at the core. And before we move on, if anyone has not read my book, then I just want to offer a free ebook version of the book, .NET DevOps for Azure, and there's a lot of the kind of the principles and thinking overlap with this webinar topic in the book. So if you just send me an email, then I'd be happy to get you a electronic copy of it for you. And if the print book sold anywhere technology books are sold. And another resource you might be interested in is the Azure DevOps podcast. It's been going strong since 2018. If you search any of the podcast directories for Azure or for DevOps, then the show is kind of reliably up into the top few results. So you can look at that. And then also, there's a new video show that was just started in 2022 called Programming with Palermo. And there's quite a good catalog now. I think 26 or 30, something like that, episodes up and running. And you can look at that. Now, as we get into the content, I'm going to launch just a quick poll, and it asks just two questions. What version of .NET are you currently using? And then what do you primarily work as? Do you code all day? Do you code and supervise others, or do you mostly do management? And we'll just kind of leave that up for a second so that everybody can get their answers in. And by the way, I'm going to move through this content as quickly as I can to leave a little bit of time open at the end if there's any questions. If you do have a question, pop it into the Q&A window. I'm pretty good at answering questions as we go along, so I invite you to do that as well. So, all right, thank you for that, and share the results so that we can see kind of who we're working with here on this webinar. All right, so let's dive into the content. So most software teams are not moving at the pace that their companies really would like. And one of the ClearMeasure Way tools is a self-assessment. It's easy to find on the ClearMeasure website. One of the subjective questions that it includes is, are you happy with the pace of software delivery in your organization, in your team? And most respondents are not able to answer a resounding yes. And we're going to talk about that. And if you look at the Standish Group, Chaos Report, and other groups that do surveys and reports of the overall software industry, we are still an industry that's very, very immature and doesn't give good results on average. Half software projects still fail. Half of the software projects, the people who funded them wish they had not. Even if the project completes, it's so over budget And it has blown the calendar by such a long duration of time that the people who spent all the money on it wish they could go back in time and not do it or do it differently. So we have a long way to go as an industry, but my goal for you is that you be in the top 10% of the industry, that you be the ones who are having great software projects and great success. So let's dive into the topic of why we might not be moving as fast. So there's a lot of businesses that have decided to have internal software development teams, and for companies that are high tech, that are tech companies themselves, they have to do that. They absolutely have to for their market. Now, for others that are not high tech, like maybe they work on railroads or warehouses, it's a judgment call. And over the last 25 years or so, a lot of technical companies have outsourced the creation of software to dev shops and to other contracting companies. And over the last 25 years, they lost a lot of money. There was even a Hollywood video made about 15 years ago, kind of making fun of the state of the industry at the time. But companies like that, they lost a lot of money and they didn't get what they thought that they were going to get. And they shifted to operating software engineering teams in-house. If they were going to have problems, at least they were in-house and they could have some hope of managing them instead of just, yelling at a vendor. And they still consider custom software to be strategic for them. But in this manner, they want more control by hiring their own employees. But they're then frustrated that they don't actually have more control. They might have more visibility, but a lot of them are frustrated that they have the in-house team, but that just having them in-house doesn't automatically increase the pace of delivery or solve other problems. And so what we're talking about here, the goal here is to go over the common categories of things that suck time, the common categories that sap the capacity of software teams everywhere. And my hope is that once you understand where all your team's time is going, then you can make decisions to change that and redirect their efforts to get the progress that you want. So there's 5 categories of work for a software team. There's actually working on the software, building the code, new features, and good changes. There's diagnosing or fixing or reworking past work that we thought was done, bugs. Then there's diagnosing or fixing the software as it runs in a production environment. Those are our production issues. Then there's administrative work, which is not work on software, but work for the company nonetheless. And then there's time off. There's time where team members are just taking personal time and not on the clock. So let's kind of go through them. Working on the software. Now, working on the software is where we want to maximize the effort. We want all of our team to be working on new software. This is where we build new features, make important changes, enhance the features so that they work even better. And this is all of our internal and external requests. The customers are asking for things. They think, our customers and our users, they think that our team spends all of its time in this category, but in reality, some teams struggle to even get a little bit of time to work in this category. It just depends on the given day. This particular category includes everything, by the way, everything in the software development lifecycle. That's even talking about the vision for a new feature is part of this category. Doing analysis, doing architectural prototypes, figuring out the options for new changes. That's in this category. Doing routine maintenance on our software. That's in this category because it's a valuable change. And even things like renewing a certificate or renewing an SSL certificate, that's in this category. It's expected, important work. Maintenance is important. It's important changes to renew certificates, to upgrade libraries and things. That's important, valuable changes. It's the work that we can see and the work that we can forecast. This is the type of work that software engineers and architects sign up for. The other categories on the list are work that the team has to do in order to get back to working in this category. So let's go to the next one, which is diagnose or fixing or reworking the past work that we thought was done. Now, this is the first type of work that is absolute waste. This is where we realize that something is broken. Something we thought was done is not actually done. Something that was supposed to work in a certain way, it doesn't work in that certain way. Something's missing. Or maybe we're surprised that now that thousands of users use our software, our maybe computing performance in some of the areas is just terrible. We didn't count on some database tables growing to the size that they've grown to. And we're spending time figuring out why we have a problem. And then once we've reproduced the problem, we're trying to redesign something in the software so that it fixes the problem. And we're lamenting that we didn't catch this problem earlier. And we're hating life in general. Or, perhaps we just made a change and something else in a seemingly unrelated part of the software breaks. And we don't understand how that could possibly be related, how that could possibly happen. But that's the second category of waste. Fixing things that we thought was done or redoing work that we already did. Next category is diagnosing or fixing the software in production. In this category, it's all about production issues, no feature bugs or build breaks or bug reports from UAT testing. This is in production. This category is for all the time spent investigating an issue in production. Maybe a user submits a trouble ticket or a piece of our software goes down and we have to restart a service or a server, or a user has a question that has to be escalated to second level support. Not only do we need to spend time to figure out if it's just user education, maybe that accidentally made it to the software team's queue, but we also have to spend time to learn about the part of the issue that may be a genuine defect. And part of this category of work is properly equipping our own company's customer support team with a better knowledge base so that they can handle more basic customer issues so it doesn't take away the team's time. Not all of the issues, not all of the trouble tickets or questions should be coming to the software team. Part of this category is also alerts that the production environment is sending to the ticket queue. Something's kind of going wrong. The system's not down. It's not a business disruption, but there is an alert that's being sent that needs to be investigated. Also, part of this is when executives or salesmen call for special support because they want to do a customer or an investor demo and they need some extra data pushed into production or a test environment or a demo account, so that they can do the demo because it's a hot new sale, hot new customer, and we need some extra support. In general, this category is for any time spent by the software engineering team because the software is in production being used by real people and there's nobody else to do that work, okay? Next category is administrative work, administrative non-software work. This category is probably the easiest to describe because every department has it. You got the company picnics, the staff meetings, the department all hands, you got the potlucks, you got the birthday dinners, you got the generalized training, even checking email or having to reinstall some software or reformat a computer, rebooting computers because a bunch of Windows updates forcibly installed themselves. Now it's time to reboot. All of that is time spent at work, but it's not related to the software team's work of delivering software. So you're always going to have this administrative category. And then the final category is time off. Time off is always going to be there. And it's not a category that we want to optimize. It's going to be there. People need to take time off. We just need to recognize that it exists and should be a part of our forecasts, especially around Christmas and other holidays that generally affect who's at work and are going to affect that working capacity of our team. So I want to talk about the first priority. The ClearMeasure way encourages us to sequence in order the establishment of quality first, then the achievement of stability in production, and then a focus on increasing the speed of delivery. We have to play some defense before we can focus on offense. Once we're focused on speed, if we haven't established the right level of quality, if we haven't achieved good stability in production, we're going to be on the losing end of the capacity equation. Our team's capacity is going to constantly be stolen away from us. It's the bed we make, and we have to sleep in it. The good news is that it's our bed, and there's straightforward known practices for establishing quality, known practices for achieving stability. We just have to put them in place. And we have tons of content going deep into each one of those. But we just have to put them in place. Well, let's kind of break down how to increase speed, how to go fast, and how to arrive at a destination. Let's think about, why might my team be moving slow? Well, let's look at your objective or your target, your kind of business objective to be your destination. We'll see a map on the screen with a little pin, say, hey, we want to go there. Maybe you're launching a brand new software capability, a new application, big new feature, or maybe you're making some changes with a goal of increasing something. Like if you're in e-commerce, maybe increasing your per order size. You want to tick that up an average of $2 per order. Or maybe another scenario, maybe you're making changes that you expect is going to lower your Azure monthly bill. But either way, you have an objective. Your objective is that destination on the map. But you also have to know where you are and then chart a course to your destination. The course that you chart is like your turn-by-turn directions on a roadmap. And we talk about roadmaps a lot in software. Your roadmap is going to contain development items, new features, changes to existing features. You identify each of the segments of your roadmap. They are things that need to be built with the expectation that you'll arrive at your destination. Now, here's the problem. We don't have a very good track record of plotting roadmaps for software in this industry. As an industry, we have about a 33% batting average. You know, in baseball, it'd be 300 or 333, about a third of the time. Even as some of the good things that Scrum brought to our attention, the product owner concept inside Scrum, that theory, it hasn't really played out. No company has such a person that can fill this product owner role. No company has such a person that can actually prioritize the right features and changes that is going to plot the right course to our destination. The Puppet Labs study, I believe it was in 2019, kind of surveyed and studied a lot of things, but one of the study was around the product owner and found that across the industry, product owners, about a third of the time, identify and prioritize the right features to accomplish the goal, and those things go into production, and it was a good change to make. Another third of the time, the prioritized features are built and put into production, and they don't make any difference. They don't actually move the needle at all. They don't get us any closer to our destination. And another third of the time, the features that are prioritized and built and tested and put into production actually hurt things. They actually take us further away from our destination. It turns out we were trucking away from our destination. Things are made worse, and we need to hurry up and back out those changes. So while it's an interesting concept, this product owner or this such a person who is such an expert, so in tune with the customers that they're going to prioritize and identify all the details of what should be done and somehow always be right about that. That actually hasn't happened. And so to get to our destination, we need the right course. We need the right turn-by-turn directions in order to actually make it there. It makes no difference if we're actually going really fast. If we're zigzagging all around and going in the wrong direction, we need the right course. So what's the answer? We need to iterate faster. We have to take the first step in the course and then stop, take our bearings, see how close we got, see if we're off track, course correct, and then plot the next leg of the course. We aren't good at plotting the whole course at the start of the journey, or think at the start of a project or a major phase. So from a thought process, we want to we want to minimize the distance to our destination, just like when you're going on a map. We want to minimize the work, and we don't actually know that at the start. We actually don't know what that means at the start. We only have a guess. So iterating is our answer to this problem. Now, next, we're going to talk about actual speed. We need to maximize speed. If we're on a really good course, it doesn't help if we just aren't going very fast at all. And the best way to maximize speed is to, or maximize progress is to minimize work, so we can stay on track and we can course correct really quickly. And by the way, airlines run this way every day. Airlines are immediately off course when they get into the air, and they're constantly taking their bearings. The wind is blowing them sideways. That's why autopilot is so impressive, because it's constantly course correcting. Now, a mistake that a lot of teams sometimes make is by accepting work into the software team that varies in size. Okay, so assuming that we have the next bit of work that we think is going to be valuable, the next valuable changes. Sometimes the work comes in and some items we know just intuitively, oh, that's really small. That's not going to take any time at all. And then others come in and say, oh, that's a big item. That's not going to be quick. Now, using estimation techniques in our industry hasn't really panned out for our industry. It hasn't worked. Planning poker, estimating by Fibonacci numbers, it hasn't actually worked in practice across the industry. Now, what has worked is using Kanban's WIP limits, or work in process limits, and standardizing the work size. Now, there are plenty of teams who started with planning poker, maybe using Fibonacci numbers or whatnot, and then they realized above a 1, 2, or a 3, the estimate just isn't worth much at all, because there's so much you can't see. So even people who have employed estimation and actually become good at this found that they had to ignore estimates that were not really small anyway. Okay, so what has worked is work in process limits and standardizing the work size. Let's talk about that. What has not worked? No, let me say it a different way. We don't want to push work into the development team that's more than one man day of effort. Before we put hands on the keyboard, ahead of coding, changes and new features, you want to break them up into units of development that are no bigger than one day of effort. Okay. Our industry has learned that if a unit of work is estimated at 2 weeks, it'll be about 4 weeks or more. If it's estimated at 2 days, it'll be 4. There's so many people that get an estimate for somebody. What do? They immediately double it, because we all know that nobody's good at estimating. And there are some scientifically proven, reliable methods of estimating, but they require special training, and they're not very widely adopted. So if they're not widely adopted or widely trained, then effectively they're not being used by most teams. Feature points is one of those. And I had Capers Jones on the Azure DevOps podcast talking about that. And from an empirical standpoint, it's actually a very good estimation technique for large projects, but it requires special training. And most development teams, because the industry has exploded, so many companies have developers these days, but the vast majority, I would say almost all of them, are not going to staff somebody who's specially trained in function points estimation. And there's no other form of estimation that actually works. And so another practice that works as a substitute is just breaking it down and splitting up the work. Now, splitting up the work does ensure that we understand the work and that we've decided on design elements of its implementation. Because once coding begins on something, we don't want to have to stop it because of a gap in understanding. We need to keep up the pace, or else our team is going to move really slowly. And if something is going to run long, then it's better that a one-day item run for 2 days, allowing us the opportunity to shift gears, get a better understanding, or abort it if we realize, oh yeah, now that we've gotten into it, this is really going to take the whole month. It's like, no, then we're not doing it. Let's do something else. We want to stop the bleeding if that happens. Now, on larger items that we're going to allocate a week or 2 weeks because that was the estimate, well, we don't find out that it's not going to work or that it's actually 3 months of effort. What, until a whole month's gone by? That doesn't work. So smaller items gives us more opportunity to course correct. We also minimize work through simple, known designs that we've implemented before, design patterns that are trained across the industry, and also by reusing defect-free components. So NuGet is your friend. Now you don't want to grab just any library that's not being used by anybody, but the well-used libraries with high ratings that tons of people are using, those libraries have already been debugged. They work, they do a good job. And so the more we can reuse those, the better. And commercial components, those are tremendous. There are so many fantastic commercial components out there, way better than taking a general purpose developer and say, hey, try to write something that's almost as good as Infogestics Grid or TreeView or something like that. No, just use the commercial component. Finally, refactoring is our friend. It keeps the code base easy to understand. The point of refactoring, and listen to this, the whole point of refactoring is to make a change and have the resulting code be as if this new feature were planned to be in the software all along, okay? We want to change the software so it doesn't look like a bolt-on or doesn't look like an afterthought, but it looks like it was meant to be that way from the start. That's a good quality refactoring. All right, so now we're down to what actually saps our speed. Okay, we're actually working on the software, and we're going to town. Now we want to move fast. What saps our speed? Well, there's two components of speed. One component is productivity per person, and the other component is utilization. Productivity per person is a measure of how many items one person can get done each day and each week. And for that, we need the proper skills, we need good automation, and we need excellent tools for our people to use. We serve a lot of clients all over North America, and we see too many teams with generalist developers who are given every assignment under the sun. Developers are used, they're accustomed to learning things. And they're not typically good at judging when a certain path is going to be a black hole, or finally they say, oh, I'm stuck. And if someone has ever done if someone has never done a certain type of work before, train them first, then have them do the work. It's the same thinking as sharpening the axe before cutting down the tree. Swinging a dull axe at a tree 100 times, it may eventually chop down the tree, but it's 10 times more effort than using a sharp axe, and it's going to take 10 times as long. You also want to liberally use automation. Our industry knows how to do so much automation these days. Private builds, multi-level testing that makes up the testing pyramid, automatic creation of release candidates of every nature of websites, databases, containerized applications, and then automated deployments, automated monitoring, alerting, and help desk and issue resolution, automated run books. I mean, our industry has gotten pretty darn good at automation. In today's world, there's no excuse to have your team doing manual builds and copying files to servers and configuring settings by typing or remoting into servers or checking in the Azure portal, looking at individual logs. Everything should be automated, and it's pretty easy to do these days. The builds, the test, everything, all of it automated. And here in the year 2023, our industry knows how to do it. And then finally, I mentioned tools. if your team doesn't have the best tools, then they're not going to go fast. Just like a race car. If you want speed, you need equipment. You actually need a good car, and you need good components for that car. Some of the basics are a super fast computer and network, ReSharper and other Visual Studio productivity add-ins, whatever your team asks for. Largely, if you've hired well, they're not going to ask for frivolous things. They're going to ask for things that actually help them work better. And then lastly, on this topic, let's go into utilization. So productivity was the first one, but then we have to have some pretty good utilization. And this is really a huge problem for why a team isn't moving fast enough. And in this area, it's not that the team isn't working very much. Problem is the utilization is low. The team, and man, I know so many teams over the years who care so much. They work tons of overtime. The team may be working 100-hour weeks, but if all the time is going to diagnosing bugs or production issues, then very little time is actually going to new features or valuable changes. And so from a cost perspective, when your business's executive team looks at it, your software is super expensive to maintain, because from a financial perspective, working on bugs or production issues, well, that kind of goes into the maintenance financial bucket, as opposed to the R&D financial bucket. Now, there's some companies that don't really track them in that same way. All they know is, oh, our software team costs a whole lot and we're not getting much from it. So what do we do? But just from an outside perspective, very little budget in this case is actually going to new development. So there's two things that we can do to fix this problem. First one, we can prevent defects. The second is we can prevent production issues. Think about it. If we prevented all the defects, we wouldn't be spending time hunting down defects. If we prevented the bad production issues that cause these business disruptions, we wouldn't be distracted by diagnosing and having these fire drill scenarios that just suck away all the time. Okay, so now we have plenty of other content around practices and tools to use for preventing defects and preventing production issues. But the first step is realizing which one is your nemesis. Is your system always having trouble? Do business disruptions constantly sabotage your day? Or are defects a big problem for you? Do you have a feature backlog as well as a bug backlog for your team? Are you having to prioritize bugs because you have so many? The biggest problem and reason some teams can't move fast is because they don't have much time left to write new code after handling all the problems their previous code has caused them. So a mindset change is needed first. Establishing quality has to be first. Then achieving stability in production. Then once you have your team's capacity back, then you can work on speed. When only a fraction of your team is actually working on new code, thinking about speed isn't going to get you much. All right. Now, we have plenty of tools to help you increase quality and stability and work on speed. I'm just going to give you a few teasers because we've gone kind of deep into each one of them. But if you've never seen them, you might want to browse our content catalog. I'm just going to give you a few teasers. And by the way, reach out if we can help you with any of them. Far too much here to cover everything in this short webinar, because each one is a webinar of its own. What you see here is an automated DevOps environment. This is basically the structure and flow of a pipeline implemented with the common Microsoft tools. And by the way, using Azure pipelines for build and source control versus using GitHub and GitHub Actions for build and source control, totally the same process, just a different tool. It's no different tool, but it's the same process. By the way, this is only the top third of the poster. It gives It gives you in detail everything that you should have in every step. This is what the full poster looks like. If you'd like a copy of this, we have a high resolution copy. It's meant to be sent to a print shop and printed on 2 foot by 3 foot poster board paper and hung up on a wall, glossy finish, real nice. If you'd like a high resolution PDF of this, then just send me an email, or Johnny can help you out in the chat. But go ahead and request that. Also, we have specific guidance around how to manage your version control structure. There's specific ways that we recommend structuring Git repositories and the relationship between Git repositories when you have a system that's broken down into microservices or maybe just multiple applications. This structure is important to establishing quality at the system structure level. And there's some mistakes that people make that kind of hinders them down the road. And so that's a topic that you might want to look at as well. We also have guidance for individual Visual Studio solution structures. If your system is decomposed into multiple Git repositories, then each one of them has its own Visual Studio solution. Well, we have guidance around how your solution structure should be implemented. There's specific ways to handle references between projects and the allocation of library dependencies among projects so that you have proper separation of concerns and dependency management. Again, making some mistakes there can hurt you down the road. And when I say down the road pretty quickly. It's not like it takes years for that to catch up. It catches up with us pretty quick. We also have guidance around private builds and continuous integration builds. They have to be done in a certain way to bring the value that you're looking for. So we have guidance on that. And we also have PowerShell automated build templates. You don't have to build these from scratch. And whether it's GitHub Actions or Azure Pipelines, the built-in templates do not do what you need to do. They're basically a glorified compile statement. You don't go with the out of the box. You need to have things done a certain way. So we can help you out with that. Now, finally, and we'll get to some questions. Finally, we have tons of success stories. Here's 3 of them on the screen. We love to see our clients have a fully empowered and effective software team. And we want you to be world-class at delivering software. We believe that when equipped with a complete professional work environment and strategically determined process, that you'll truly become world-class. We hear of teams that move fast and do good things at the big companies like Google and Microsoft and others. But any of your teams can be just as effective when equipped properly. They can. We really believe that. And so ClearMeasure's mission is to empower software teams to be self-sufficient, able to establish quality, achieve stability, and increase their speed. And that's the ClearMeasure way. And we have many resources on our website. We love one-on-one meetings as well. Those are free consultations. We don't charge for them. We just love talking to people. And if we can help further, that's great. And by the way, a lot of the resources on our website are free to use, and we can answer your questions about them. And of course, we are a software architecture company, and we're here to guide you along your journey to effective software delivery. So that's a lot of content. I hope it got you thinking. And we'll move to take some questions. You can go ahead and just put them in the Q&A window. Fred asks, can you offer any proof of Kanban success? Academic papers would suffice. Fred, I don't have those at the tip of my fingers here, but we have your email, so we'll follow up. But yeah, I agree with you. You want to look at empirical evidence and whatnot. Thank you for that question. I appreciate it. If there's any other questions that come in. Okay, here's a question. On the automated build front, do you have any samples or templates that we can use? Can you send them? Yes, we do. I don't have a link to them in this webinar, but if you look up the Programming with Palermo video show, and there's a link to it off the ClearMeasure website, there is one of the episodes that specifically talks about continuous integration and automated builds, and it walks through and has a link to a complete Git repository with the complete build template, Visual Studio solution structure, the testing pyramid with unit tests and integration tests and full system tests. And it also has release candidate packaging into a Docker container, along with automated SQL Server database migrations. So it has a whole lot packed into one Git repository. So look for that episode, and you can go deeper on that. That's a lot of content. No way to fit into this webinar. Okay, one comment here. We're using Kanban. We have dropped OKRs, looking to run small project sprints in conjunction of bug battles with upfront investigations before actioning. Thoughts? That sounds great. I don't know what level of OKRs you were using, but that stands for objective key results. But small project sprints, the smaller the better. The more iterative, the better. And a lot of people who are getting started, if you got two backlogs, a feature backlog and a bug backlog, well, you have to tackle it somehow. But either way, the point is, you're never going to get your handle on your bug backlog if you continue to generate new bugs. And so the smaller the better. Make sure you're using the testing pyramid. Make sure that you're not writing any new code without any new tests. Make sure you're not changing old code without a safety net. Old code that's been there for a long time, and especially code files that are too big to actually understand quickly, you need to write characterization tests around that code. That's just a test that exercises the code as it sits, as you understand it, and as it works. And that gives you a safety net so that if you accidentally change the behavior of how that code operates, then you have a test that's going to fail and give you some notice that you accidentally changed something that you didn't intend to. So I think that's a great starting place, Richard. Next question from Scott. What do you recommend as the best approach to projects which lean towards being of an experimental nature, but carries expected deliverables? Well, if there's, and every project's going to have expected deliverables. There's no project that I've ever seen that literally is funded but has no expectations. So, it's perfectly viable for a project to be a research project where the purpose of that project is to deliver a proof of concept of some new technique or new technology. And in this case, that type of project, the goal of it is to answer a question. Is this new technique going to work? Is this new technology going to work? And you basically have to decide how much you're willing to invest in getting that answer, because nothing ever has a blank check. You go into that type of experimental project not really knowing what you're going to do, but the objective tends to be the answering of a question. And in those cases, I've seen it be really successful to have a certain allocation of scheduled time and say, you know what, if we can't figure out that the answer to this question is yes within 1 week, 2 weeks, 3 weeks, whatever is appropriate in your situation, then we are not going to go forward. We're going to assume the answer is no for now. So I guess that's my thoughts on that, Scott. All right, next question, Joe. So if you have smaller sprints, do you typically align releases with the end of sprints, or are the releases on a different schedule? I guess that depends on the ability to measure whether a pivot is needed based on the work completed in the sprint. So you use the word sprint in several places here in this question, Joe. And I think that Agile and Scrum brought a really good thinking to the industry in the last 20 years, way better than the thinking in the 90s, which was, let's do design for 3 months, and then we'll do coding for 6 months or 9 months, and then we'll be into the second year testing, but we still haven't released anything. So Agile broke away and said, hey, start iterating more frequently than 1 or 2 years. And Scrum basically brought a hard line in the sand that said we should have 1-month sprints. And then a lot of people said, oh, let's do 2-week sprints. Now, extreme programming from 1999 introduced the concept of iterations, and a lot of people using extreme programming jumped to 1-week sprints right away. If an organization already has Scrum entrenched, I advocate for 1-week sprints because that's a natural work cycle anyway. You have 5 work days, you have a weekend, and aligning your sprint with, non-software work like sales teams or marketing teams or shipping tends to be 24/7. There's so many other teams that align a work cycle with a day and then a week, because that's how our calendar works. And so I think that's a natural cycle to do a 1-week sprint. And then you could, if you're not used to releasing into production every week, or in your language, every sprint, then that's the goal to work for. And even if the only change that's ready to go is the fix of a spelling mistake, you should be able to deploy the next version into production. It doesn't matter that there's only a few things to deploy. If you have a proper development environment, and of course the buzzword is DevOps, but just think of what it functionally is. If you have a proper environment for your team to work in, then you ought to be able to make those small spelling mistake fixes and then just deploy to production. You don't even need to wait until the end of the week. You could, if it's a small change, oh, it's a spelling mistake, I fixed it, let's just go to production, the deployment's automated. And yeah, your first step may be to automate the deployment, but in order for deploy, because of your architecture, it requires 10 minutes of downtime or 30 minutes or 1 hour of downtime. Okay, well, then you're going to have to do an off hours deployment for now, but start analyzing and evaluating the architecture change that would enable you to do a 0 downtime deployment. Once you modify the architectural elements that are preventing it for now, well, then you can do a deployment in the middle of the day, because you don't actually have to have an outage window in order to deploy. And then that enables you to do deployments whenever, any day, anytime, because it doesn't become a business disruption. And then the focus turns back to, okay, how can I do more and more classes of changes really quickly? Spelling mistakes, I get, but now we need to make some behavior changes. Well, you need to make sure you have good test coverage so that you're not relying on a human test process to catch anything that goes through. The development team has actually built in their own automated safety net to let you know if you broke anything. So I hope that fully answers the question. That was a good one, Joe. That was a good one. All right, going through, it looks like all the questions have been answered, and the earlier questions I was able to work in to the content during the webinar. So these are great questions. Thank you so much for being here. I appreciate you. All of you can do it. I believe in you. You have what it takes. You do. You have what it takes. You can do it, and we're here to help. And so thanks for coming. I will put back the slide, by the way, with my contact information, so that everybody can have it. And it's right there. All right. Perfect. And anyway, thank you for all your attention. Hope everyone has a great day, and God bless.